Hi, I am Dr. J.C. Lu, the NASA Chief Scientist for Orbital Debris at the Johnson Space Center.
And hi, I'm Brian Corley, the lead of the ISS Trajectory Operations and Planning Group at the Johnson Space Center.
Welcome to Mission Imagination. How did you get into this line of work? I came to Johnson Space Center as a postdoc research fellow more than 20 years ago.
From a very young age, I used to love math and science. I also enjoyed building things and, more importantly, taking them apart to understand how they work.
My initial research focused on the dynamics of asteroids, comets, and meteoroids in the solar system.
Ultimately, I achieved an aerospace engineering degree and figured what better place to put that into practice than here at Johnson Space Center, where we send people into outer space.
What is orbital debris? The term orbital debris is used to describe any human-made object in Earth orbit that does not serve any useful purpose. Typical examples of orbital debris include spent rocket bodies, retired spacecraft, and breakup fragments generated from explosions or collisions of rocket bodies or spacecraft. Why do we care about orbital debris? There are two reasons. First, the increasing number of orbital debris in the near-Earth space environment. And second, the high impact speed in space. This aluminum block is about ½ an inch thick, and this penetration damage was caused by this tiny object here. Its diameter is only 1/8 of an inch. The impact speed that caused this damage was 7 kilometers per second, which is actually lower than the average orbital debris impact speed at the International Space Station altitude.
How is the crew protected from orbital debris? The space station has shielding to protect it from small particles about the size of the end of your fingertip, or 1 centimeter. For larger particles about the size of your fist, 10 centimeters, we can track those from the ground. If they pose a risk to the space station, we actually move it out of the way. If the space station were to be penetrated by orbital debris, the crew is trained and has procedures to detect the leak and patch it to save the ISS. How do avoidance maneuvers work on the International Space Station? The first step in protection is tracking the debris. The Air Force uses radars to track the 23,000 objects in space that are larger than your fist, and they notify us if something comes within a certain volume of the ISS. This is a highly choreographed process which involves mission control in both Houston and Moscow, since the engines to perform the maneuver are Russian-controlled. Under typical circumstances, we have a couple days to evaluate the risk and plan the maneuver, but it can be performed in as little as 3 hours. If the risk is higher than 1 in 10,000 and the maneuver cannot be performed, the crew will enter their respective return vehicles ready to perform an emergency undock should a collision occur.
How do we manage the orbital debris problem to better protect future space missions? The most important step to manage the orbital debris problem is to limit the generation of new debris in the future. There are existing policies and guidelines at NASA and at the international level to limit the generation of new debris. Orbital debris is a very difficult problem. It will require a good international effort to mitigate the orbital debris problem to better protect future space missions.
Now it's time for you to put science, technology, engineering, and mathematics to work, something we do at NASA every day.
Good luck on challenge number 4.
Inspire,
Explore,
engage,
Mission Imagination.